So, all right, in this video, I'm going to be showing you how to identify outliers in a data set. Now, what we're talking about outliers basically, these are numbers that are very, very far away from the rest of the data. For example, in a distribution that is normally distributed, or in an histogram type of graph. For instance, let me give you an illustration. If you have a graph like this, you have let's say you have an histogram like this. Just pardon me, I just quickly want to explain. You have something like this, and you have another one like this. You can see that these data sets are close to each other. Maybe at the end of it, you are now having some other ones like this, and these ones are also like this. You can see that this, okay, let me say this, these two data values are far away from the rest that are close to each other in this histogram. So these two data values are said to be what? Outliers. Outliers in the sense that they are very far away from the rest of the data. So that's just a concept. However, there is a formula that can be used to determine outliers in a data set. So for us to know if outliers exist, outlier will exist if the number does not satisfy this range. So this is the range in which the numbers must satisfy. That is Q1 minus what? 1.5, right, multiplied by IQR. If you check my previous video, IQR represent interquartile range, and we have what? Q3 plus 1.5, right, times what? Q what R. So now if the result we get for this particular set of numbers, if the numbers we have, or the number given in the question, does not satisfy this range of numbers, then such number that doesn't fall into this range is said to be an outlier, meaning that if the histogram is plotted, to be far away. So let's check some numbers and see if an outlier exists, and then we can look at this. So let's look at these numbers that I want to give you. Let's say we have, okay, this question says for the set of numbers, check if outliers exist. So these numbers we have 11, 31, let me write this, 11, 31, 21, 19, we have 8, we have 54, we have 35, we have 26, we have 23, we have 13, we have 29, and we have 17. So if you look at this set of numbers, let's look at it. And for us to determine the range of numbers to know if outlier exists, we need the Q1. The Q1 is the first quarter or the lower quarter, and we need the interquartile range. And we can't get Q1 until we arrange this set of data in ascending order of magnitude. So the first thing we need to do is to arrange the numbers in ascending order of magnitude, meaning that from the lowest or the least number to the highest. So what's the least number in this series? That is 8. So let's arrange. So arranging it, we have what? 8, we have 11, then we have 13, we have 17, we have what? 19, we have 21, we have what? 23, we also have 26, we have 29, we have 31, we have 35, and we have what? 54. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you look at this, the number of entries we have there, n in this case is 12, which is what? Even. So if n is even, first of all, we need to split this data set into equal halves to be able to know the point at which the median will be determined. So basically, we have to first determine the median. That's what I'm trying to say. So if we split it, we are going to be having 1, 2, 3, 4, 5, 6, 6. So this is half of the data. So meaning that the data has been splitted into 2. right? And of course, for you to get any of the quartiles, you must first get the median of the whole data. So the median will now be the what average of these two numbers, right? So the median, that is Q2, will be what 21 plus 23 divided by 2. Basically, we are not interested in Q2 anyway. So the next one is for us to get Q1, and Q1 will now be the what the median of the what upper half of the the lower half of the data, while the what Q3 will be the what median of this other half of the data. So the median for this one will give us the Q1. So we have 6 numbers here, so we split it into 2 on this side, we split it into 2 on this side. So in that case, this is our Q1. So Q1 here will now be 13 plus 17 divided by 2. So 13 plus 17 divided by 2 will give us 13 plus 17, that is 30, divided by 2, that is what 15. So Q1 here is 15. For this second half of the data, we can also split it into 2. So we pick these 2 to this side, we pick these 2 to this side. So this is the what Q3. You notice that I didn't calculate Q2 because it's not required in the formula, though that's the median. So this one Q3 will be what 29 plus 31 divided by 2. So Q3 here will now be 29 plus 31, that is 60. 60 divided by 2, that will give us what 30. Okay, so now what will now be our IQR? So IQR is what Q3 minus what Q1, and that will give us Q3, that is 30 minus 15, and that will give us what 15. So we have gotten all the necessary values that will fall in the range. So let's now see if outlier exists. So outlier exists if we have, so let me just say that I will just put it like this: outlier exists, right, if the number does not fall into the range of what that is Q3 Q1 rather, Q1 minus what 1.5, right, times what IQR, comma what Q3 plus 1.5 times what IQR. All right, so now let's see what is our Q1. Our Q1 is 15. So in that case, we put it here: 15 times 15 minus 1.5 times the IQR, and that is what IQR is also what 15 minus 1.5 times 15, comma Q3, that is what 30 plus what 1.5 times IQR, that is what 15. So if you do the mathematics very well, this one will give us what minus 1.5 times 15 minus 1.5 times 15, that will give us minus 22.5. Then so that would just be what 15 plus minus 22.5, or you can say that 15 minus 22.5, that will give us what minus 7.5, right? Then this one too, 1.5 times, that's 15, and that will give us 22.5. 22.5 plus 30, that will give us what 52.5. Okay, so now if you look at this is the range we are talking about. Let me put it here. So we can say that the range we are considering is from minus 7.5, right, to what 52.5. So any number that fall into this range, right, is still active. But any number that does not fall into the range of this number is said to be an outlier. So let's go back to the data set. The maximum number we have here is 52.5. Do you have any number that is above 52.5 from this data set here? Yes, I can identify one. 54 is above 52.5, and of course that is the highest, and there's no other number. All the rest of the numbers will enter into that range. The range is actually minus 7.5 to what 52.5. So every other number will enter this range except 54. So based on the information we've gotten, 54 is an outlier. So we can conclude that what 54, right, is an what outlier. Right, I want to believe that this video has helped someone. Please Don't forget to subscribe, like, share, and please do the needful thing. Thank you for watching this video. See you in the next video. Bye bye.